All right, so we're going to jump right in here. One of the things we learned from the last panel is, in a lot of ways, it's just really all about the data. And so you saw a bunch of startups that were helping companies do more interesting things with their data sets. What we've got here for you now is the big enterprise perspective. So we've got 4 data-driven businesses that have got these incredibly rich and powerful data sets, and we're going to hear from their heads of machine learning what they're doing to use that data to create incredible products. So I wanted to introduce Ravi here. So Ravi's the technology editor at the Financial Times. He's been there since the turn of the century, which makes it seem like a lot longer. And so, who better to run this panel? And Ravi assures us that he is Canadian in spite of his UK-infused accent. So take it away, Ravi.
Thanks very much.
Whoa.
Thank you very much. Just a bit of housekeeping. Guys in the back, I'd be really grateful if you could just keep it down because there's some great panelists here and it'd be kind to them so that everyone can hear. Thank you, Siobhan, and thank you to all of you. I tweeted earlier, it's a pretty impressively packed house, which I think speaks to 2 things. 1, the intense interest in this topic, and 2, having seen the guest list, a lot of uncertainty about what it actually means. What does machine learning represent for businesses outside of the technology world in particular, or those that still think of themselves as outside of that world. So fortunately, we have a panel on enterprise applications of some of this stuff. A bit later stage, all of these companies than some that we heard earlier, to give us a sense really of 2 things. 1, what are they using machine learning for now? And also pitching ahead to the future a little bit. What do they project from the trenches and the front line of this stuff, us coming forward to? I'm going to do it slightly differently than Kevin, in that I'm going to ask all of them to speak and give their little talks, and then I will jump in with questions afterwards, trying to maybe pull in some trends, and then also throw it out to you, because I know there's a lot of very impressive people in this crowd who aren't on stage. So going from me that way, to my right is Gary Kazantsev, is the head of the R&D machine learning group at Bloomberg. Among other things, he's been described as one of the leading data scientists in finance, which I know will appeal to some of the bankers in this audience and those who read my paper. To his right is an example of how machine learning could have done things slightly better than us humans, in that the IBM representative has changed since the programs were printed. But very pleased to have Jerome Pacenti, who heads the kind of core technology unit at IBM's Watson program. Watson, of course, famously in 2011 won Jeopardy. He heads a team of about 300 trying to improve the core technology there, and was an acqui-hire. He started a company that was bought by IBM a couple of years ago. To his right is Jason Krosek, who is the group head of payment solution at MasterCard Advisors, meaning he heads a lot of this stuff at the finance company, working with clients and customers on how to use it better. And he has probably the best Twitter handle here. He's called The Payment Guy. And finally, at the far end, certainly not the last or least interesting, but Mike Del Balso, who heads machine learning at Uber, the ride-hailing app that's been valued at about $62.5 billion in just a few years. Beyond that, he only joined earlier this year. He used to head the machine learning effort at Google that powered its ad solutions business, which, as you will all know, is where they make most of their money. So I'm going to ask them to present. As I said, I'll take questions later, but I'm going to start with Gary. Gary, kick off.
All right. Pleasure to be here. Thank you. Excuse me. So I think the idea here is to describe some of the most compelling applications of machine intelligence for our business today and looking forward. So Bloomberg, as probably most of people here know, is one of the top financial information services companies in the world, and we process an enormous amount of information, both structured and unstructured data. So I think one of the most compelling use cases for machine learning today is the work that we do in text analysis. So we ingest about 1.25 million documents per day from about 120 20,000 different sources in 30 different languages. This is more text than any human being can read in years. But we do want to make sense of all of this stuff. So to that end, all of this text goes through a fairly involved natural language processing pipeline. So it does recognition for names of companies, people, topics, and then gets to more complicated things like sentiment analysis or predictions of market impact or a variety of other fairly complicated natural language processing problems like that. So this is not the biggest use case, but it is an important one. And if you ask me for what I think will be the most compelling for the organization in a year or two, I will probably point to the work that we are doing on question answering. So you can think of the project that we are working on as essentially Watson for finance.
All right. To give you an idea of what we can do today, I have a little video of what's going to come to a store near you very soon. So, at Watson, I joined Watson 2 years ago, and when when I started, we got a lot of customers that came to us because they thought, this is kind of a cool thing. Let's try some applications. We had people who come to us and say, let's have a little use case and try AI to do certain things. And I'll tell you that in 2 years, we've seen a complete transformation in the way people approach us. People today believe, and not just thanks to IBM, but thanks to all the development in the industry, that AI is going to change their business. So you have retailer, insurance companies, audit companies that come to us and realize that their business is going to be transformed by AI. And what we see today is that we work with these people and we find in all these areas, in how you file taxes, how you analyze X-rays, how you answer customer support questions, that it's possible not completely to replace humans, but who have these repetitive tasks, often involving unstructured information, audio, video, images, and text, to replace or to enhance the way humans do business. So we see really a tremendous interest in the industry and a perception from many, many large companies today that it's going to transform the way they do business.
Excellent, thank you. It's a bit frightening. Jason.
Sure. My name is Jason Korosek. I work for MasterCard Advisors. MasterCard Advisors is a consulting arm of MasterCard that we use to help our issuers, our acquirers, and our retailers improve their business. Now, in the information services area, what we're doing is we're converting all of the data that MasterCard has. Now, MasterCard has anonymous data. It's really all the data from all the swipes that you have, that you take every time you go to shop, right? It's actually very small in any individual transaction, in the sense that it only has a card number, a date, a time, a merchant name, and an amount. Now, there's a lot of those. There's about 16 petabytes of those over a 3 to 5 year period of time. Now, what we do is we're taking those and we're aggregating them and organizing them in ways that are very, very useful for our clients. In some things, we're taking our macro view to say what's happening in overall economy for any given country. How do we do that? We know what we've done. Because our competitors are public companies, we can take what they file in their 10Qs to expand it out to the entire economy so that we can say within a few days how well an economy is doing over time. We also do that for any type of aggregation. So you can aggregate it for a location. So you could say, how's the economy doing right here in this area based on all the transactions that are happening. Now, what's really special here is, unlike other kinds of data, aspirational data, say, a survey or what you're doing in search, this is what people are actually, where they're actually spending their money. So it's very fact-based. It's what people are actually doing. Now, the example I gave, and there's a lot of examples of this, but the example that I thought you might like to see is how we can bring this out to individual merchants and retailers. So when you think about all the retailers that are out there in the world and what they can do to improve their business, well, there's many things that MasterCard knows already. So if you take a look at how they're doing an average ticket size, every single metric will really drive towards a specific action that the retailer can take to improve their business. So if their average ticket size is below what their competitors are, that means that the consumers that are shopping at that retail are spending less time or less amount of money at that merchant than they are at their competitors. Similarly, the days between visits. If the days between visits stretches out longer than the competition, then they're visiting the competition more. Likewise, every single piece of analytics, what does it do? It drives towards a specific action. Now, when we were working on this product originally, we thought, why don't we just tell the retailer, why don't you run a promotion for lunchtime on Thursdays from this particular postal code with this specific demographic? But the thing is, merchants and retailers don't necessarily trust MasterCard with that kind of advice. So we have to pull together the analytics at scale across all merchants all at once so that they know why those recommendations exist. And that's why we present all the analytics back to the merchants. What's different also about MasterCard than most other companies, because the relationship exists, that is, the merchants already have a relationship with MasterCard, providing these analytics back out to them at scale around the world for all 36 million merchant locations becomes not trivial, but it's a lot easier for MasterCard to do to drive that intelligence about what's happening in the economy, what's happening with their business back out to all the retailers. And that's really what we're doing with our local market intelligence product.
Excellent. Finally, Mike.
Hello. So I lead the machine learning team at Uber, and just before that, I was leading the machine learning teams at Google that power Google's ads auction. So my team at Uber, what we're trying to do is bring machine learning and intelligent machines to lead the decision making in all corners of Uber. So to give an example of what Uber uses machine learning for right now, let's think of how you would use Uber. You open the Uber app, you press request a ride, you input where you are, you type your destination, and then a car comes and picks you up and drops you off wherever you're trying to go, and you get out and you don't have to tip, and a payment is made automatically. So let's kind of just like zoom into one of those steps and look at a small example of how machine learning can help. So let's look at when you're entering your destination on the app. So this requires you to type an address. And we know that like typing on mobile phones really sucks. It's very slow. You'll always make mistakes. But this is critical data to get right in this flow. You know, if you make a mistake when you're typing your address of where you're going, your driver's going to bring you to the wrong place. So what we did was we built a machine learning model to predict where you're actually trying to go. And where we surface this information is in the address bar where you're going to type your address, we actually show recommended locations like, hey, are you trying to go to the grocery store? And if you tap on that address, it selects that address as your destination. And what this does is reduce errors. It makes it a lot faster for you to use the Uber app in general. And the interesting thing here is that if you, this is a small example of how machine learning can help the user experience here, but if you chain together all these little things, these little machine learning applications that improve user experience and make it slightly more frictionless, it makes a difference between a confusing product to use and a really great product to use. And so to look at how machine learning is helping the future of Uber, think about this. There's 1 billion cars on the road, and 96% of these vehicles are not being used at any given moment. And 15% of our cities are being used to store these vehicles that aren't being used. Think of garages and parking lots. And so now imagine when your Uber comes to pick you up, imagine there's somebody in the car already. And that's another passenger going on a similar trip as you. And you get in the Uber, and on your way, the driver stops, drops that person off, and maybe picks up another person. So if we can reach the level of efficiency where we can chain all these trips together, we can reach a scale where, from the driver's perspective, they have a perpetual trip. And so they always have someone in the car. And when we reach this level of efficiency, we can push prices down very low. And it can be to the point where it challenges car ownership. So this is like ad hoc carpooling. We think this will be a game changer. And so I've already started to do this with some Uber products. But think of what that does for the number of cars on the road. So whereas maybe 2 or 3 people would be taking 2 or 3 different cars going to the same place, now you have one car. And think of how many cars that removes off the road. And obviously there's implications for traffic and pollution. And machine learning is at the core of this, because this isn't just a one-step function, turn this thing on. It's you slowly need to build up the efficiencies and optimize the system to get to this scale. Machine learning can help with things like recommending the right route for a driver to take to be most likely to pick up more customers, or also smartly matching which drivers should respond to which riders who are requesting a ride. And if we can even understand who are the best drivers with machine learning, then we can only choose the best drivers, the safest drivers to put on the road. And that will help general road safety and the safety of transportation overall. So this kind of all feeds into this future vision that Uber is trying to achieve of a smarter transportation network. And it's all about making transportation affordable, reliable, and safe. And machine learning is one of the core technologies that's being used there.
Fantastic. Thank you all. Mike, I'm going to start with you because you ended. One of the services that you offer is called Uber Pool. So I guess one of the things to emphasize with regards to Uber is that everyone knows it as a ride-hailing app, that you can kind of get a car quickly. But actually, that's just the start of a much bigger thing that's going on at your company. With Uber Pool, which is kind of it's a carpooling service, and my understanding is that the algorithm is developed to such a degree that, which I'm sure is machine learning based, that essentially you can make the ride as efficient as possible, so I can pick up multiple people going in slightly different directions, but do it without adding magnitudes of time that make it disadvantageous to the customer. Could you just give us a sense? Because I know this is an area in particular that you're investing massively in places like China, in Europe, in the US as well. How is that working for Uber Pool and that particular kind of product that you guys are offering? Okay, so
this is it's a tricky problem to define, because you have to understand the trade-offs from a user's perspective. A user will want to use Uber Pool to save money. It's cheaper than taking another form of Uber. But at the same time, they incur costs because they have to go out of the way to pick up another driver sometimes, or pick up another rider rather. And we have to kind of understand what are these trade-offs and what is the kind of model of a rider. And and like when do they prefer to not save money and prefer to go straight to their destination, and like when is too much out of the way, stuff like that. And so machine learning is at the core of like modeling that, like understanding what are a user's trade-offs, but also I guess Uberpool is helping generate like a new slice of the market that machine learning optimization can help totally change prices and lead to like new sets of new efficiencies. And that's kind of what I was alluding at before.
Yeah, it's kind of like if anyone's been into emerging markets, say where you have minibuses collect lots of people on the work, for instance, this might be a technological kind of way of doing that.
Yeah, and
but
I think
you'd argue more efficient than that.
And I think I'm not like super familiar with the situation in Toronto, but I think Uber Hop was launched here either today or yesterday.
The key thing is it's not good. Okay.
What's that?
It's not good to be an Uber employee in Toronto right now. That's the key thing you need to know.
Well, I'm based in San Francisco, so that's all I got to say.
Jerome, can I bring in you here? Because one of the things that so Watson was kind of a forerunner of a lot of the stuff with machine learning in terms of kind of reaching out to a much wider populace of understanding. And as a company, IBM has transformed massively from, when I was a kid, it was known for making hardware to being consultancy to going big in this AI space. And there's a very interesting case of the person who's been hired, former CEO of Thomas Cook travel company, to kind of head your Internet of Things operation. And she said that before she got hired, all of her future employees put her speeches and social media tweets through machine learning to discover what kind of boss she would be. Fortunately, she passed. Can you give us a sense of, at IBM, how key this whole space around machine learning has been internally transforming the company itself? Not just the clients, but in terms of the company itself. How does this fit into what you're trying to do and what you're trying to achieve, and what are the kind of implications for it in terms of how the base operates?
So you're asking, are we eating our own dog food? Is that what you're asking?
Yeah, exactly.
So we have many internal projects. We're identifying in our own company the same kind of thing we identify with our customers. So we have a big project around customer support and service. So we have a big goal of actually reducing the cost of our support operation by a very, very big number using Watson today. We also have application to make our sales force more effective using Watson. So what we sell our customers, we actually deploy internally. And what IBM is a very, very large company, 400,000 employees. So these are two applications that we have running today.
And have you seen tangible benefits to that? I mean, what are the implications have been? Is that you've been able to cut costs by getting rid of X number of people, or has it been that the process has been more efficient and more effective as a result?
It's a combination of both, right? I mean, so you're trying to make the support experience much more smooth. I mean, we all have experienced relatively rough support experience where the person you talk to is not that knowledgeable and it takes forever. So we actually measure that and figure out actually support on its own very effective. Actually, the time you get a real response is like sometimes 10, 20%. So putting a machine in the loop basically improves that experience, makes it faster, and then also obviously allows you to reduce your costs.
Okay. So can I bring you, Jason, in on this trust aspect and the data sets that you use? Because you're accumulating mounds and mountains of data, and one of the things I hear a lot from technology, not actually all companies, particularly ones that are not technology companies who are kind of trying to deploy technology in a big way, is they get all this data, they amass it, it's massively powerful. Machine learning is surely amplifying that to a degree, but how do they actually use it? How do they decipher it in a way that's effective for their businesses? Can you give us some sense of how you guys do that, both internally, but also definitely for your customers at the front end?
Well, the bottom line is analytics for analytics' sake is just academic. So unless you take some action based on the analytics that you're looking at, the value is zero. The value of the analytics then is in the action you take. So if you raise your prices, or if you offer a discount during a certain period of time, or if you target a particular postal code or a particular demographic, what's happening is the value that you get out of that, that's really the value of those analytics. And so we spend a lot of time thinking about that and wondering if we could dispense with the analytics entirely. Not that we wouldn't do it, but that we wouldn't expose it to the clients. But then it goes back to that trust factor, right? So if MasterCard comes knocking on your small business, at scale, by the way, and says, you should raise your prices because the competition, they're getting more money for the same thing, because that's something we can see in the data, right? The merchant might look at us with a little bit of skepticism, right? Who is MasterCard to tell us to do that? Or who is MasterCard to tell us to offer a lunch discount on Thursdays from this particular postal code or this particular region, right? But we do have the data to show that. And in the consulting arm of MasterCard Advisors, we've done that for a long time for our very, very, very large merchants. We've really done by making it automatic and at scale and using the machine learning around that is it really democratizes it. It brings it out to the vast set of retailers that have never had access to these kinds of analytics before. Again, without the trust, so we have to show them the analytics to show why you need to take certain actions. And unless you do that, then people, probably would they'd look askance. They wouldn't be quite sure why we would be recommending something.
How does it work also? Because you obviously have relationships with businesses, often via financial institutions like banks, for instance. So are you going directly to the retailers and the mom-and-pop shops? Are you doing it via the RBCs or Scotiabanks or CIBCs? How does that relationship work?
So MasterCard historically is a franchisor, right? So we go to market through the banks, and the banks are almost always domestic in the markets that we're working in, right? So the standard way we would go to market with a merchant would be through the financial institutions. In this sense, it would give them more substantive way of discussing things with their clients, where they can be talking to them about the types of business tactics they could use to improve their businesses. That said, if you're a really, really large merchant, then of course we would deal with you directly. But for the vast majority of our clients, we go through our current distribution system. That's our go-to-market.
And sorry, before I bring Gary in, just to be clear, you're not doing this in all the markets in which you operate as MasterCard, right?
So local market intelligence, the one product I was showing there, is available today in 20 markets, including Canada.
Okay, great. Now, Gary, one of the things you do is you kind of process mounds of financial information and kind of to get a sense of what's happening real time in markets and financial situations, right? But one of the things you said once in an interview was the key thing is asking the right question. That's the thing that really differentiates how the data is used. Can you explain that? It kind of builds on what Jason was talking about a little bit, about how the analytics is actually used in order to influence decision making for, say, Bloomberg or your clients.
Right. Excellent question. So what I mentioned are only two examples out of actually a wide variety of different applications. So to maybe mention a few others, right? We use these methods in pretty much everything we do, right? So every time that somebody types something into our product, the list of suggestions that comes up is something which is determined via statistics on user behavior, right? Everything you read, right, influences what you're recommended next, right? So there is an enormous amount of hooks, if you will, for this technology into our product, right? And the product is used for pretty much every kind of financial decision making that you can think of, right? It's used by your pension fund, it's used by your bank, it's used by your insurance company, right? It's used literally by everyone who does anything to do with financial markets, right? So some people use the output of our analytical processes, like the text analysis stuff that I mentioned, for black box trading, for instance, right, to actually execute whatever it is that they're trading. Right? Some people are using it to prioritize a list of documents that their clients will see. Right? So there is actually a whole spectrum of different, qualitatively different applications, right, that I could talk about.
So just so I understand correctly, so it's people using a Bloomberg terminal. Is the machine learning analyzing how they're using it and then learning from that and therefore responding accordingly by providing them information that's relevant?
Yes.
That's the way it's worked. So how many people here use a Bloomberg terminal every day? Those would be the bankers in the room. Okay, not that many. So have you seen tangible improvements in that? I mean, is the key thing that it improves the quality of the information as well as the speed with which they're able to make decisions and make money in the market, say?
Yes. So this goes at the question of how do you actually measure these things, which is sometimes quite complicated, right? Because every time that you create this kind of a machine learning system, right, which interacts with the user, you create a feedback loop of one sort or another. Right? So you have to be very careful, right, because you can improve certain processes to the point where that type of user interaction will simply disappear, right? So if a user was spending, say, 5 minutes looking for a particular document and now they spend 0 time because it's just shown to them, right, then the searches that you were using to actually inform the recommendation systems are no longer there. So you have to think sometimes very hard about how to actually pose these things. Have we seen tangible improvements? Yes, absolutely, right? So we do have our own customer support, for instance, and we use machine learning to route people's questions, for instance, to appropriate representatives, or even to answer them automatically, right? So that reduces the amount of time that it takes for a user to get an answer to sometimes fairly complicated questions. So that's a very easy one to measure. Overall, the mission of the company is to provide, in effect, a level playing field for the financial markets. So basically, we are in the business of improving access to information, all kinds of different kinds of information, right? And that is something that you can actually measure, right? So if we are providing analytical tools to understand, in a very real sense, understand, right? For instance, text documents, news documents, right? Then you can measure the time for market reaction, right? So basically the difference between when the story is published and when the market prices change, right? And we have consistently observed that time to shrink, right? We have been at this for a fairly long while. These products have been around for years, right? And over that time period, we look at the distribution of times, right, for price movement, following the publication of news stories, right? And it keeps going down, right? So that's another very easy way to measure, right, in a quantitative fashion, right? How well are we doing?
Jason wanted to come in on that.
I think the user experience will definitely change over time, because what happens is, again, even in the product that I showed, after a while you're going to say, yes, do you want to run an advertising campaign in this particular postal code with a discount? Yes. Okay, great. And then your sales goes up. And then we ask again, do you want to do that? Well, of course, yes. Let's do that again, even though it's in this other zip code. And you ask again and you say, well, of course I want to do that, right? At some point the user is going to be really frustrated and says, just run those campaigns on my behalf, right? That's sort of the next logical step, where you can imagine why even look at the analytics that are telling you what to do, because you can see demonstrably your sales go up every time you take that action that's recommended.
Actually, before I throw it out to the audience, on that point, Jerome, the demonstration you showed of Pepper, that curious robot, so it was cute and intriguing and curious, but of course it wasn't necessarily super emotional or superhuman, which when you go and buy something is part of the sale. You close the sale by having that relationship thing. And before I ask you a very quick question, was anyone freaked out by that machine they saw and buying a TV like that? If you had a Best Buy, would you like to do that? God, you guys are all cool. So the question I have for you is just, can you give us a sense about, I'm assuming you're working on trying to develop this emotional response so it's much more human-like in its interaction with a person, but powered by machine learning. Can you see a point in the near future or distant future where that's going to
Sure, it's a good question. So, emotion is a big part of the experience of human to human. So it's something we pay a lot of attention to. If you actually have the opportunity to interact with Pepper, it's quite remarkable how it makes a little emotional connection already. It follows your face. It has face recognition. It kind of understands a little bit your posture, and it moves its arm. Try to be very lively. It's a really different experience from any other robot you have seen before. Okay, it makes a difference there. We are working on emotion, recognizing and generating emotion. told you about yesterday. We'll have some things coming actually next month, really unique. But today you can recognize emotion in faces, you can recognize emotion in voice, you can recognize emotion in the text and the words you're using, and very soon you'll be able to generate emotion as well. That's something we all work. It's part of the experience, and it's part of the the experience that you need to have with the machine as well.
I kind of liked how the eyes got really wide when they saw the customer.
That's right.
So I have a follow-up question for you. When I first saw the video, it seemed to me that like at this stage the technology is not, it's not super practical in Best Buy, for example. It felt like slightly like you're talking to like those robots on the phone, right? And I'm sure you're trying to get to a point where it's just as good or obviously way better than an in-store employee. And you mentioned that emotions are one part of that. I'm wondering, like, are there other critical challenges that are in the way before you feel like the performance of that robot exceeds the performance of an in-store employee?
So, yes, similar question. So, one is that it's also an entertaining experience. So today we are talking with a lot of retailers or hotel chains that feel like putting, a robot, in a lobby or, in your bank will kind of give a different experience, a different, feel to the, a different branding to your experience. So there is a plus to it. Okay. Now the robot is not completely replacing a salesperson. But it has a fairly, we're working a lot on dialogue interaction. It's not just you ask a question, you get an answer. The system will actually recognize the state of the interaction, will react to your state of mind as well. So we're working on all these aspects. We're not trying to replace completely the human. We're trying to take on simpler tasks that humans do and do this. I mean, if you have, the question you have about a TV actually are not, a huge number of questions. And you can actually have a system that has better knowledge than the humans when it does that specific task. So it's not a pure replacement. It gives a different experience. It can answer more deeply certain questions, and and it's just complement actually the human experience in the store. We're not going to replace all the salesmen there.
On the Uber case, actually, because of course it's a very different interaction in that the interaction with the company and the service is not via really a human. I mean, it's the app itself is so incredibly efficient, and that's the experience you're trying to maximize, isn't it, and make work as well as you can. I mean, presumably that poses a different set of challenges and issues and makes it a little bit easier to kind of implement machine learning in the way the company operates.
Yeah, so everything goes through the app in some way, and just the fact that everything goes through the app makes it makes it a smoother user experience than like just using a taxi, for example, from the beginning, because payments happen automatically through the app. And it also opens up a lot of opportunity for machine learning. So one thing that, one of the examples that I thought of that we're using that came up, that something we said earlier reminded me of, is actually through like customer support example, where we said like, okay, you can use machine learning to like route tickets and understand, automatically classify what type of complaints people have, so you can like quickly or more efficiently deal with them and send them to the right people. But when we have so many rides per day, we reach a scale where we can actually take machine learning a few steps farther than that, and we have enough data to begin to understand like what these tickets are about, and actually at that point have enough data to see how our customer service representatives have responded to them and have dealt with them, and we can make a machine learning model to predict how they will respond to these tickets, and then we can recommend specific responses to the customer service representatives as well, and sometimes do it automatically when we're very confident of what it is. So you can imagine like it might be pretty easy to understand and classify if a specific example or a specific complaint is like, hey, I lost my hat or whatever in this Uber. So that might be a very specific thing, and we can now use machine learning to detect that and then choose which appropriate action is to follow after that. And sometimes that's just contacting the driver and connecting the two so they can meet up.
Okay, Orwellian universe comes soon. We can ask some questions. I'd be grateful. There's some mics coming around. Let us know who you are and where you're from. And if you don't have any questions, I can ask many, many more. Anyone? There's a gentleman at the back there, just past Tiff.
Hi, my name is Eric from Huawei Technologies. I have a question for Jason, actually, for MasterCard. Because I know when you do the analytic reports, a lot of them comes from data scientists and data analysts that really goes through to generate those data generate models in order to generate reports. Now with the machine learning, I mean, so previously, of course, with the machine, I mean, they're good for correlation, but it's hard for them to do causation. But now I know there's a trend in machine learning where they're actually starting to try to figure out how to do the causation for that. So do you see in the future, perhaps, that could, perhaps makes the data scientists or data analysts, those people go obsolete?
Well, certainly, anytime you do something at scale, and if there's anything that you should walk away with, MasterCard's about scale, right? We do things in a global way, and we touch businesses in a global way. So when we have the econometric models that are being produced on an individual basis before for potentially a very large bank or a very large retailer, what we would say is we would work to make sure those econometric models would be done at scale so that everyone could benefit from that. Every small retailer or even smaller banks or credit unions and that kind of thing.
Very optimistic.
Question over here.
Yes. Hi, for the payments guy. So I have seen that you are using retailers' data. Therefore, you might, do you need to get their permission? Do you have to pay them to use the data? And then are you able to sell them back the results of the analytics?
So first of all, the data is from each swipe that goes through. So every time a consumer swipes the data, it goes through from the retailer to the acquirer to MasterCard to the issuer and then back to the consumer. And in that, it's anonymized to begin with, so there's no consumer information. We don't know who that is. All of that is cleansed. What you find, what happens is a lot of this stuff is very, very dirty. And so we clean it up, and then we aggregate it back for the client that wants to get it. And so if it's a large merchant or a small merchant, we aggregate it back and provide it back to them. I think I hit your question. So the permissions are given by the consumers and the retailers at the time that the transactions happen, and then at the time that they're getting the analytics.
Right here. Lady there, please.
Hi, my name is Rupinder. I'm from Bell Canada. We're seeing most people in this room probably understand that we've been collecting consumer data for a long time. But we are seeing some more sensitivity around privacy, and people are kind of coming to know that we're collecting a lot of data about them. Do you see privacy and the issues around data privacy either disrupting the momentum around machine learning or having you change your strategy in the near future?
Can I just ask you quickly, are you seeing that at Bell Canada, that people are raising more questions of you as a company?
I think telco in general.
Telco in general, okay. And who is the question directed to in particular, anyone? Or?
Pam.
Cool. How about Uber guy? Mike?
So I used to run some of the machine learning systems that make predictions about if you're going to click an ad, for example. And so that's very personalized. We want to understand, sometimes it's very useful to understand some stuff about you so then we can make sure we show the right ads. And I do think that close attention to privacy is something that has slowed down the innovation process there, but it's for a good reason, and it's just a necessary cost. For example, I worked on these systems for 2 years, and I was never once able to look at anybody's personal data. There's very strict privacy rules at Google, and that led to us having to go through a whole bunch of extra kind of like anonymization and all these other processes for the data so that our systems can learn from it, but not actually see what the actual data was for each person. And that just led to like a lot more work to be able to handle this data properly, but that's what you got to do if you want to respect privacy.
In the case of Watson, we actually work with, we do the B2B. And so our customers force us to have a lot of clarity about what we do with their data. One example is in health. What's good in health is you have HIPAA, which is very constraining, but at least it's a rule that everybody can follow. So we know what the rules are. I think for general, data, we need also this kind of clarity from every vendor to say, so what can I do, what will I do with your data?
I just wanted to add that privacy is extremely important to MasterCard. When in the data warehouse, we make sure that there isn't any consumer information in there, so there's no name. So when we talk about all those transactions that come through, we don't know who they belong to, right? That's how we start it by design.
Okay. Right. So we have this problem in spades in some way, right? And we have to think about this issue very carefully, basically in everything we do. So if you think about, for instance, even something as simple as recommending news stories to people, right? It presents some non-trivial challenges when you're dealing with, say, a news story about a merger or an acquisition or something like that, right? Or, well, actually, let me give you a more concrete example. Right? So you look at the list of news stories which is ranked by readership, right, on a Saturday morning. Right? Unless you take special precautions in the design of that system, right, the number of users who are going to be using that system at that time is very low, right? And therefore, you may inadvertently expose non-public information. So if a particular desk at Goldman, for instance, is working on a merger or an acquisition, and they're reading a lot of stories about a single entity, right, that is not an acceptable outcome. Right? So to answer your question, yes, we have had to modify many, many different things that we do right at the outset by design, so that these kinds of things are strictly excluded, that this cannot happen. Right? The list of people who has access to this information in any way, shape, or form is so short that I can probably number them on the fingers of my two hands. Right? So, which in a company of tens of thousands of employees gives you an idea of how seriously this stuff is taken.
And there were cases in the past where allegations that someone had looked at what someone was at their data and what they were looking at, and maybe sold them a service against I think a Buber, weren't there?
There were allegations, yes.
On which note, I've been shown a sign saying time is up. I know there are more questions. These guys are hanging out, so please do ask them questions. And I hope I've proved, along with Kevin, that there's still a room for humans to moderate panels. Join me in thanking these guys for a great session.